Hello GATE aspirants. Welcome to part 12 of GATE Atomic and Molecular Physics series. Question number 14. Among the term symbols 4s1, 2d 7 by 2, 3s1 and 2d 5 by 2, choose the options possible in the LS coupling notation. Now for the first case 4s1, we know multiplicity is here, so 2s plus 1 is equal to 4. That gives us S is equal to, S will be 3 by 2. Now S is 3 by 2 and this is S. That means L is equal to 0. And if S is 3 by 2, L is 0, then J, and here it is given that J is 1. And from here we can say it will be, it can be 3 by 2 only. So from here, from the values of L and S that are given, it will be 3 by 2. So this is not matching. So this cannot be. So option A is wrong. Now let us check for second one. So 2d 7 by 2. So 2s plus 1 is equal to 2. That gives us S is equal to half. So S is half and L is equal to, this is D, so L is equal to 2. So L is 2 and S is half. So J can be L minus 1 to L plus 1. So this will be 3 by 2 or it will be 5 by 2. But here it is given 7 by 2. So this is not matching. So here I will write, this is 1 and this is not matching. 7 by 2 it is not matching. So again option 2 is also wrong. Next we have 3s1. So that means 2s plus 1 is equal to 3. So that means S is equal to 1. S is 1, L is 0. That means J will be 1 only. And this is 1, 1. So this is matching. So option C is correct. For the last option 2d 5 by 2, we have 2s plus 1 is equal to 2. So S is equal to 1 and L is equal to 2. So J can be 2 minus 1, 1. 2 plus 1 is 3. Oh, sorry. This is 2. So this will be half. So this will be 3 by 2 or it will be 5 by 2. So this is matching with 5 by 2. So if any one is matching, then it is fine. So D. So option C and D are correct and option A and B are wrong. So C and D. This was MSQ question. Option C and D are correct. Next question. To sustain lasing action in a 3-level laser as shown in the figure, necessary conditions are: option A, lifetime of energy level 1 should be greater than that of energy level 2. Now this has to be metastable state. So for lasing action, this has to be metastable state. So that means its lifetime should be greater than that of level 2. So option A is correct only. Now population of the particles in level 1 should be greater than that of level 2. So yes, in metastable state it should be larger for population inversion. So option B is correct. Second is lifetime, third is lifetime of energy level 2 should be greater than that of energy level 2, no. And population of the particles in level 2 should be greater than that of level 1, no. Level 1 should have a larger population, it is metastable state. So only option A and B are correct here. Next question. The spacing between two consecutive S branch lines of a rotational Raman spectra of hydrogen gas is 243.2 centimeter inverse. So that means 4B is equal to 243.2 centimeter inverse is given. After excitation with a laser of wavelength 514.5 nanometer, the Stokes line appeared at 17611.4 centimeter inverse for a particular energy level. The wave number in centimeter inverse at which Stokes lines will appear for the next higher energy level is. So wave number for the Stokes lines which will appear for next higher energy level, that will be equal to mu naught minus this 4B, and mu naught is given 17611.4 minus 4B is 243.2. So that is equal to 17368.2 centimeter inverse. So here answer is 17368 and answer given in the answer key is 17367 to 17371. Next question. The transition line as shown in figure arises between 2D 3/2 and 2P 1/2 states without any external magnetic field. The number of lines that will appear in the presence of weak magnetic field is. Now in weak magnetic field, this is anomalous Zeeman effect. So 3/2 to 1/2. So transitions are 6. Or you can check it. This is 3/2. So energy levels, possible energy levels are 3/2. Then we have 1/2, minus 1/2 and minus 3/2, and this state is 1/2 to minus 1/2. So transitions are from 3/2 to 1/2, then this one, so these are possible transitions for delta mg corresponding to +1, 0 and -1. So 6 transitions are possible. So answer is 6. Answer given in the answer key is 6 to 6. Next question. Consider the atomic system as shown in the figure where the Einstein A coefficients for spontaneous emission of the levels are A21 is 2 into 10 raised to 7 per second and A10 is 10 raised to 8 per second. If 10 to the power 14 atoms per centimeter cube are excited from level 0 to level 2 and a steady state population in level 2 is achieved, then the steady state population at level 1 will be. Now here N2 is given 10 to the power 14 atoms per centimeter cube. Now steady state is achieved at level 1 as well. So that means dN1 by dt, this has to be 0. But this is equal to, now dN1 by dt, the ones which are decayed from level 2, they will come in level 1. So that means it is proportional to N2 by in the T2, and also they are decaying to 0. So that will be proportional to N1 by T1 as well. We are using this formula. dN1 is proportional to N1 dt. So dN1 is equal to, since it is decaying, we will have minus sign. So minus of lambda, and then we will have N1 into dt. But lambda is 1 by tau, mean life or lifetime. So this will be N1 dt by tau with minus sign. So dN1 by dt will be minus of N1 by tau 1 for the decay part and also for this decay part of 2. So for it will be plus 1 because of it number will be increasing. So this is equal to A21 into N2 minus A10 into N1, and this is equal to 0 in steady state. So from here we can write N1 is equal to A21 upon A10 into we have N2. So that is 2 into 10 raised to 7 upon 10 raised to 8 into, this was 2 into 10 raised to 14. So this is equal to 2 into 10 raised to 13. So here we have to calculate value of x. So x is equal to 2. So answer is 2. Answer given in the answer key is 2 to 2. Next question. The spin s bar and orbital angular momentum L bar of the atom precess about z bar. The total angular momentum, z bar is the total angular momentum, and z bar precesses about an axis fixed by a magnetic field B1 bar is equal to 2 B naught z cap, where B naught is a constant. Now the magnetic field is changed to B2 bar is equal to B naught x cap plus root 2 y cap plus z cap. Given the orbital angular momentum quantum number L is equal to 2 and spin quantum number S is equal to half, theta is the angle between B1 bar and Z bar for the largest possible value of total angular quantum number Z and its component ZZ. The value of theta is. Now simply we need to calculate angle between these two because they are preceding about Z. So L is given, S is given. So from here J is equal to L plus S, which is equal to 5 by 2. We have to calculate it for largest possible value of Z. So largest possible value is L plus S, which is 5 by 2. Now cos theta is equal to B1 bar dot B2 bar upon magnitude of B1 bar upon B2 bar. So B1 dot B2, only z cap term will survive. So this will be 2B0 into P0. So B0 square upon its magnitude will be 2B0 and its magnitude will be 1 square plus root 2 square plus 1 square, which is 4, and its square root is 2. So that is 2 into B0. So this is equal to 1 by 2. So cos theta is 1 by 2. That means theta is equal to, in degree it will be 60 degree. So answer is 60 degree. And answer given in the answer key is 27 to 93. And here we are getting answer 60. Next question. The spin orbit effect splits the 2p to 2s transition. Wavelength lambda is 6521 angstrom in lithium in two lines with separation delta lambda is equal to 0.14 angstrom. The corresponding positive value of energy difference between the above two lines in electron volt is m into 10 to the power minus 5. The value of m is. Now this is 2p. So 2p transition. This is transition to 2p to 2s. This is one transition. It splits into two transitions. So this 2p will separate out. So this is 2p 3 by 2 and 2p 1 by 2. And this will be 2s 1 by 2. Now this is lambda 1 and this is lambda 2. And its difference is also given to us and we have to calculate E. Now E is equal to hc by lambda. So delta E will be hc by lambda square into delta lambda. So this will be hc, value of hc is 1240 electron volt nanometer into delta lambda is given 0.14 angstrom. So this will be 0.14 angstrom upon lambda square is, so this can be converted into nanometer, so this nanometer will cancel. So 652.1 into nanometer into 6521 angstrom. So I have written value of lambda square and I have converted it in one value I have converted in nanometer because I want to cancel this. So this angstrom and angstrom will also cancel and answer will be in electron volt. So delta E is equal to 4.082 into 10 to the power minus 5. Rounded off to nearest integer, it will be 4 into 10 to the power minus 5. So value of m will be 4. And answer given in the answer key is 3 to 5. So these were all the questions from GATE 2021 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.